I know that the UA community always has lots of questions when it comes to solar energy and solar power and what they need to know when they're thinking about including it in their renovation or their building project. Can you actually explain to me what are the components that are included in a solar energy system, all of the bits and pieces that go together, and sort of what role do they each perform in getting power from the sun to into your house, basically?
Yep. Obviously the components that everyone sees sitting on people's roofs are the panels, and they are what absorbs the light and turns the photons into energy. And I sort of think of them as the muscle. So they're the bit that captures the sun, and then the brains is the inverter. So the inverter is the bit that manages the voltage. It makes sure that, because the panels get DC power and we use AC in our home, so the inverter converts the power, manages the voltage, keeps us safe. Then, of course, there's frames, depending on what your roof is made of, how it's fixed to the roof. If it's a tile roof, there'll be a frame attached to the tiles and the panels are attached to the frame. If it's a colour bond roof, then the panels are attached directly to the roof. There's the wiring, and that regulation has changed around the wiring in the last 10 years or so, but it's compliant. There's regulations around that, and you get your certificate of compliance at the end. Then depending on what kind of a system you have set up, so as I said, the inverter is the brains. Most systems have one inverter. So it's what's called a string design, and you can have two strings going into one inverter. So for example, you'll have some panels on the west side of your roof and some on the north, or some on the west and the east. So they're a string each. They go into one inverter. There is another type of inverter called a micro inverter, which means every single panel has its own little mini inverter. And those work a lot more efficiently, but they're a lot more expensive. So they're usually recommended in instances where there's a tricky roof. So panels are going to have to be placed in all sorts of strange spots rather than in one line or one batch. Or if there's shading issues, so that some of the panels are going to get some shading, then you want to maximize their output with a microinverter. Or if you've just got a very small roof, you just want to make sure you get the absolute maximum amount. But because they are more expensive, a lot of suppliers will just quote you on a string design with one big inverter. The inverter usually sits somewhere near your switchboard. And once it's done all those things, kept us all safe, managed the voltage, turned it into AC power, it goes through your switchboard. And that's the point at which you use it in your home. So you're using it straight from the roof effectively. So when it's daylight and the panels are generating power, you're getting the power for free straight from the roof. If you don't use it, it goes through your smart meter. And unfortunately, you do have to have a smart meter if you want to get solar installed. So that is a slight additional cost. But it's something that's being rolled out anyway. So people are having to do it anyway. It goes out of the smart meter if you don't use it and out into the grid, and someone else will use it. And you get paid a feed-in tariff for the power that you send out to the grid. So as we all know, we buy power and there's a rate per kilowatt hour. And it's the same with what you sell to the grid, but it's a lot smaller. So similarly, if you can use it when the daylight is on the panels and you're generating, you're using it for free, you're going to get the maximum savings.
Gotcha. Okay.
So that's the basics.
That's fantastic.